In Year 5, children will start to manipulate and know numbers up to 1,000,000, which means they're going to be doing calculations involving numbers which have greater than 4 digits, as in this addition calculation here, which means that base 10 is no longer fit for purpose because it only goes up to thousands. So when using manipulatives and representing their work pictorially, children will now show counters instead of base 10 equipment. So if a child was to be doing this calculation, 32,651 plus 11,258 pictorially, this is how they would represent it in their book. They would first start off by drawing a grid with the relevant number of columns and labelling them as in previous years with ones, tens, hundreds, thousands, and tens of thousands. And because I am doing an addition equation, I would put my plus sign there to show that's the sort of calculation. So I'm going to start by representing my first number here in the top part of the grid, and because it's an addition, and same as with many calculations including subtractions, I would start with my furthest right hand column, which in this instance is a 1. So I'm going to draw, if I was a child I would be drawing my counter, which represents one lot of 1. Next column, my tens column, I need to show that I have 5 lots of 10. So I would draw in my book 5 counters representing 5 lots of 10s. And then the next one to do would be 6 hundreds. And when the children do this in their books, they may use different coloured pencil crayon to show the different values, or they may just use a plain circle but label it with the relevant value. Now I'm not going to carry on showing you how to draw these values because in the Best Blue Peter tradition here's one I prepared earlier. So my top row represents 32,651 and I'm going to total it with 11,258, and you'll notice that we've set out the counters very clearly so it's easy to see how many there are, particularly note the dice formation for the 5s. So to find the sum of these two numbers, I'm going to count them up and see how many I have altogether. Being an addition, it doesn't matter which order I do it in, as long as I have stayed within the same column. So I'm going to start with the number in the bottom row here first of all and count on 1, 2, 3, 4, 5, 6, 7, 8, 9, and I'm going to record that in my equal sign. 9. I'm now going to total my tens column. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 lots of 10 I know is the same as one lot of 100. So I'm going to regroup this into one set of 100, and I'm going to show this by pictorially showing I've grouped it by drawing them together in a group by putting a circle or a similar shape around them. So I have exchanged my 10 tens now for 100, and I'm going to draw my 100 counter to show that and label it 100, because instead of having tens I've exchanged it for the 100. That's in the same hundreds column. I now no longer have any tens, so I need to show this by putting in a 0 as a placeholder because I have 100 instead of 10 lots of 10. I'm now going to continue to find out how many I've got altogether, and because it doesn't matter which order I do addition in, I'm going to start with this number here: 100, 200, 300, 400, 500, 600, 700, 800, 900 in total. And then what is the sum of 2,000 and 1,000? It is 3,000. How many have I got altogether? 1, 2, 3, 4 tens of thousands. 4 tens is 40. 40,000. 43,909. I'm going to check this equation now in the abstract. 1 plus 8 is 9. 5 and 5 make 10 altogether. 10 times 10, 10 lots of 10 is 100. I place my 100 in my hundreds column where I've exchanged it, and I'm going to show that I don't have any tens by putting in my 0 as a placeholder. I'm now going to total the number of hundreds in my hundreds column. 6, 8, 9. What is the sum of these two numbers? 2,000 and 1,000, 3,000. And then all together I have 4 tens of thousands. 4 tens is 40, 40,000, 43,909. Same answer as I had in my pictorial representation. In the abstract, you'll notice that we have commas that separate our groups of hundreds, tens and ones from our groups of thousands. So it's really important that the children remember to do this in their abstract writing. And we would encourage them to start doing that as well in the pictorial, bearing in mind in the abstract the comma is very clear, not to be confused with any number that may be carried or exchanged, and that it's not confused with a decimal. Likewise, in the pictorial, that it doesn't get mixed up with any value that may have been exchanged or carried over.